And welcome back. As we go ahead and continue working with our loops, we're going to go ahead and take a formal look at break and continue, which are two ways for us to kind of work with loops. Now, break and continue are, again, two different terminologies. They have very similar functions, but they, of course, are ways that we can address this issue that we've had up to this point, which if we want to exit a loop, pretty much we've had to say, hey, we got to get a Boolean expression to become false. All right, so for example, we had, let's say, num is less than 5. We had to find a value for num that would make that false. However, there are other ways that can either pause a loop or exit it completely. The first, of course, is the break statement. Break statements are how we stop the current iteration of a loop. Break statements completely stop it. Once you hit a break, you're out of that loop. There's no way to get back into that loop. And we've seen break statements before when we've been using switch statements. You'll see that there's a break part in there. And when we looked at our continuous input program, we've had a break there as well. Now we have a better understanding of how and why a break statement works. Then we have the continue statement, which is simply just going to pick a loop back up wherever that last iteration was. A continue statement merely just ends a loop iteration and then is going to continue that loop onward. Now, there are some necessities that we need to talk about here in usage with loops. Well, first thing you have to understand that break and loop aren't required. There are ways for us to go ahead and look at our code and say, like, well, could we rewrite our code in a way that I wouldn't need to break out of this loop? Or is there a way I wouldn't need to use continue? Well, any code that uses either statement can technically be written to use the same thing without break and continue. Obviously, if we're doing like an infinite loop, this could be a little more complicated, but that's necessarily the goal of our program, right? It's necessarily to break out that way. And typically, continue is one of those things that is a lot of times avoided because it can make our code sometimes difficult to read because of all the different use cases and stuff that can come in with it. Break is far more common. Now, when it's placed inside of an inner loop, the break or continue statement is only going to apply to the innermost loop. And we'll talk about multiple loops stacked on top of each other here in a little bit, but we aren't going to worry about that right now. Just kind of note this, that how this works. So, for example, one of the things that we might encounter is if we have a switch statement inside of a loop, or, let's say we have an if-else statement, any kind of break statement, but particularly switch statements because we use breaks, are only going to apply to that innermost loop or the switch statement. If the break statement is labeled also with an identifier, we can then exit any label loop, not just the innermost loop. And again, don't worry about this concept of innermost and outermost loop because we're going to look at this when we talk about nested loops. I just want to get you familiar with some of this idea of how these different pieces are going to work. So, labeling a loop is a great way for us to go ahead and start finding identifiers. So when we start looking at like nested loops coming up, this is going to be a way for us to say, hey, this is the outer loop, this is the inner loop. So for example, if we want to identify this loop, here we have a do while loop, and inside that do while loop, you can see we have a while loop. So the way we can identify that outer loop is we can simply just put this identifier outer loop here, and they'll tell the program, hey, we're going to put this identifier in a colon here to say, this is the outer loop. Now, if we actually look at that break statement here, the identifier outer loop, of course, again, identifies the outer loop, which was a do while loop. If the number in this case, in that example, was negative, but it's not less than 100, then the inner while loop is just going to end normally. However, if the number read in is less than negative 100, then the labeled break statement is executed and it ends the enclosing do loop. So it's very important that we kind of have an understanding of how, when these loops are nested on top of each other, how they're going to end up working. Now, you can label more than switch statements and loops, as almost any statement can be labeled. So labels they can be very helpful. They're not a requirement, though, so you don't have to worry about, like, oh, do I need to start going through and labeling my loops or my conditionals? No, you don't have to do those, but they're great ways for helping make your code get some clarity. A labeled break can be handy. For example, if you have a switch statement in the body and we want a break statement that just ends your loop, rather than ending the switch statement. And if we go ahead and come on over here to Eclipse, we can take a look at break and continue and how they are going to be working here. You can see inside of here we have two if statements here for both of these. This first one's going to demonstrate continue. The second one's going to demonstrate break. And one of the things you can see here with my continue statement is that I have, in case both these are testing the same thing, we effectively have these programs do the same thing. We're looking for a mystery value. But in the continue statement, you'll see I also have this count plus plus that's also here that's not in the break statement. I'll show you why here in a minute. But we just go ahead and run our code. You can see the continue statements here at the top says looking for the mystery value, and then it says, hey, could this be the mystery value? Could this be the mystery value? And so it runs through it all the way until we get down here to the break statement, which is saying looking for the mystery value. So if we look at these codes, and I take out this count plus plus just for a second here, and I go ahead and rerun this, you'll see that we have a infinite loop in place here. And the reason for that is with continue, when it tests this and it finds that value of 5, that's technically true, but it never gets to this bottom count plus plus and says, oh, this is 5, go ahead and restart your code. And then it's going to go ahead and try to run through it again. If we don't have anything that changes that value, for example, if we were getting user input, it wouldn't be a problem. We could just get user input, and we could go and handle that accordingly, go back to the top loop. Continue works great for instances like that. But here, because I'm just not changing this value of count, there's nothing to change this value of this variable, I have to put this count plus plus here as well, because otherwise what is happening is that it's going to be stuck here, always seeing 5, never getting a chance to change. Whereas if we look at the break statement, it sees 5, and what does it do? Oh, it says, oh, that's the mystery value. I'm going to go ahead and get on out of this loop. I don't need to do anything more. So there are advantages to both, but again, you're probably going to see break more often because a lot of times with break, you're looking for a specific use case, and with that specific use case, you want to maybe terminate a program or exit out of a loop or have some kind of thing, for example, like a switch statement, and you wanted to handle that accordingly.